Hello everyone, my name is Hunter and welcome to my CS4620 database final project presentation. And so what I did was I built a Metacritic web scraper and database. And so it's all written in Python, interacts with a SQLite 3 database as we've learned in class. The files specifically are two different web scrapers, a page scraper, which will scrape the page URLs for the individual game pages and then put them in a CSV like this called game URLs, which houses so many URLs. There's over 19,000, all from Metacritic. And then those get sent into the review scraper, which will go to each individual page on Metacritic and scrape the data we need from those pages and then put it into our database. From there, we can use our database application program to interact with the database and query and get any of the cool, interesting data we want about the various games. We also in here have Metacritic's game.db, which is our database file, and a backup file because you never know. To run the file is pretty simple. Just run them. Just run them from wherever, idle or the command line or, excuse me, wherever. All you need is a database with the right schema called, Metacritic Games. You also need some of these libraries. You may potentially have some already, but if you don't, these are the libraries you will need to download. And then these are some libraries that are also used that I believe should come with Python, but are just useful to mention anyway. All right. To detail our schema first real quick, so we have two tables. Game, which has an ID, a name, a developer, a publisher, a rating, a metascore, a user score, a release date, a platform, and cover art. And then genre, which is a multi-value attribute, which has the genre and an ID as well, and the key being the ID and the genre together. And the ID is obviously a foreign key to the ID in game. And so the reason we kind of do things like this is you might wonder, because Metacritic has multiple copies of the same game. Each game on a different platform has its own page because there's different scores, potentially different release dates, potentially even different developers. So I do it like this, where only genre is a independent, or not independent, a multi-value one, because I treat every single other one as its own individual entry to avoid having six plus tables, because developer, potentially publisher, release date, the scores could all be multi-value. Platform as well. And so that helps simplify the database a little bit. And that's what the ID is for, to kind of keep track of the individual entries, because name can be repeated. And so to our actual code, here we have the URL scraper, basically, the page scraper, which basically, goes to this page, and this page can be any, year. It goes, even though it goes before 95, it only has entries starting on 95 up to more entries. And so it basically goes to each year and scrapes the URLs for all the games on that page, doing this, and puts all those URLs in that CSV, as we said. Before 2000, there's only one page each, so we have to change up the program just a little bit, but that's what it does. And then it feeds those into our review scraper, which will go to individual pages like this and scrape all that data that we talked about, get everything from here that we need, and put it in the database. There is some error checking here because sometimes certain pages lack certain data, such as here on Undertale. We can see Undertale has no rating, while The Witcher 3 does. And in that case, we make it NA. For any text, we make it NA. For numbers, we make it 0 if we can't find anything. If we can't find the title, we return. You might ask how that happens. I think some URLs are dead. Not many. I think it's only about 10. I think a few URLs are dead and their pages no longer exist, even though they can still be scraped. And so that is how that works, and that, as we said, feeds all the data into the database, puts everything in here, and then the genre in here, and that gives us the database that we use here. And so let me real quick, let me clear this off. You didn't see that. This is the first time you're seeing it. Ooh, it's cool, right? First time you saw it. And so this is the program, and so we obviously start with our menu, which lets you search for games by a variety of different, desires. So you can search for a specific game, and you can search for all the data about a specific game. You can search for groups of games, or search by all that different stuff we talked about, from developer to the scores to the genre and the platforms. You can also search for art. And we even have us using some queries that mix stuff and some graphs. So starting from the top, let's go to 1. So here at 1, what we do is we ask for a entry to a name. And so that specifically says not case sensitive, but the game title must be exact. And we'll get to that in a second, and I'll show that. So right here, see, you can type, whatever you can. It doesn't have to be case sensitive, so you can type The Witcher 3 Wild Hunt like that, and then get a developer, get a publisher, get a Metascore. And you get all the Metascores on all the platforms. It's pretty cool. Now let me show. So let me just see if let me show you how we just type The Witcher 3. You get nothing, because the way we are querying that is using like. And so like allows us to not be case sensitive, which is very nice because it's easier for the user to input stuff. They don't have to worry about specifically entering the title with the right, upper cases and stuff. They can just type it, but they do have to be exact in the title and the exact name, because we're not using wildcards. The reason we do that is because if you used wildcards, you could have an incident where, say, let's do something like Fallout. You can just see, you just get the developer of the original Fallout. The problem is, there's other games called Fallout, Fallout 2, 3, 4. In this instance, you just want stuff about the original Fallout. With wildcards, you could get data about those, or even with, like, The Witcher has expansions that include The Witcher 3 Wild Hunt in the name, so if you weren't exact, you'd get stuff for those expansions as well that you may not want, like their scores. And so that is why we query, everything, and we just use distinct as well, because we only want one, again, because there's multiple copies. We could get multiple, so we distinct to get only a single version for the game we look at, using like without a wildcard, because we don't want to worry about case sensitivity, but we want to be exact, so we only get the information about the exact title that we want. And you get all that information we showed. Now, so here's, let me show you something that, so exit, and let me show you something that does let you do a little bit with wildcards. So here in 2, we can search for all the games in the database, and that will actually output it to a CSV. That doesn't do everything in the database per se. It puts everything from the game table, so all of this data. It doesn't do the genre, but it puts all of the game table data into a CSV that you can look through at your leisure. It's actually quite quick. It only takes like a second or two, which is quite surprising for how big the database is. You can search all the games in the database, which is 19,000, so we won't show that off quite right now, but you can see all the games in the database if you wanted to and look through them without the CSV in the other data. Here's where we include some wildcards. So search, not case sensitive, but it doesn't have to be exact, because you can do something like A. There's all the games with A. Or, as mentioned previously, the Fallout. All the games that have Fallout in the title. And we do that through, let me get to it, we do that through using like again, but with some wildcards at the end. So that way, at the end of a title, you can, it just kind of fills in the blank, so you can do that where it's like, oh, I want to find all the games with A, or all the games that start with the, or something like that. And so it's just a very simple, selecting the distinct names, again, because we don't want the repeats, but using like to avoid case sensitivity, and using a wildcard so we can have a little more fun with it. We also have some counts. Let me just show one of those real quick. So count just all the unique titles. So there's over 12,000 unique titles in this database. About 19,000 entries total, about 12,000 of which are unique titles. And so all that stuff's, some fairly simple stuff, select star and then put into a CSV, select distinct name, And here again, using like, and for pretty much anything textual, we're going to be using a like to avoid case sensitivity. Sometimes with wildcards, sometimes not. The basic way to describe my methodology with that is wildcards occur where we don't really care about being specific. So we just want to know all the games that start with a group of letters. So we can just use the wildcard. Whereas we don't want the wildcard, we want to be exact, such as we just want to know all the info about one specific game, or we want to know all the info about one specific developer, which we'll see in a couple seconds. And here are pretty simple, just counting our IDs, counting our distinct names, counting the names where we have the wildcarded variable being like something, and that's where all that comes into play. Now 3 and 4 are somewhat similar because they're developer and publisher. They have a lot of the same features, but so you can search for all developers, you can search for developers with a specific set of characters. So yes, let's search all ones that start with B. So this is all the developers start with B. Let's see. I believe, yeah, I like that Black Muffin Studio. So let's search for all the games developed by Black Muffin Studio. It's one game, Night Call. And just to reiterate, it's not case sensitive, but you do have to be exact. So if you just type Black Muffin, you get nothing. Again, the idea behind that is when we're just searching for all the developers, we don't really care to be specific, so we just use the like with a wildcard so we can just get all this information because we don't really want to be specific. But when it's about a specific developer, we don't want the wildcard because we just want to know about Black Muffin Studios. You know? Maybe there's another studio in there called Black Muffin Games, and so if we just typed in Black Muffin, we would get stuff about both of them, and we don't care about Black Muffin Games, we just want Black Muffin Studios. That's, again, the methodology behind it. Again, because it's text-based, a lot of likes with the wildcard or not, depending on how specific we want to be. Getting all the developers as a distinct developer. The counts, again, just counting what we need, counting distinct, counting with the like and the wildcard if need be. Publisher, to just briefly look at, is pretty much all the same stuff, just swapping out publisher for developer. I'll show that off just real quick. Search for all publishers with a Z. So you got that. Let's search for all games by ZeniMax Media. I believe they do it. Yes, they are responsible for some Elder Scrolls stuff. I believe they own Bethesda. So just you can see how that works. Just pretty much the same way. We'll show just a count off real quick because we didn't before. Just counting all the unique publishers that show up. Right here, just counting the distinct publishers and whatnot. Alright. Now, here we have the ratings. So ratings aren't super involved. We just have, the ratings. There isn't a ton to do with them, but you can just, you can find the ratings, you can search for specific ratings, count them. A lot of the same stuff, We want to be specific here, so it's a like without a wildcard. Here we don't really care, so it's like a like with a wildcard, counting the ratings. We do, I believe, have a group by here. This is the only real instance of a group by, because we want to group the ratings by each other, so I'll actually show that because it's a little unique. So you can see all the occurrences of each rating. That uses a group by, so we can count each rating and have them be shown for each rating, the number of times each rating occurs. So that's a unique query that we use. And again, just a lot of the same stuff. Scores do things slightly differently in that we're using greater than, less than, or equal to when you're looking at specific scores, and you count them. So you get, here we want to get the name and the platform because we want to know the game on the specific platform, because different platforms for the same game can have different scores, as we can see here. So 6 Metascore. Search for all games greater than a specified score. As we saw earlier when we looked at The Witcher and it had 3 different scores for 3 different, platforms. So just real quick, yep, all the games greater than 90. You can also average as well. And so it's just, a lot of the same stuff, selecting the data, the name of the platform, where the score is greater than, less than, or equal to. We use equal to because it's, a number. There's not any ambiguity there. It's just the number. And then we count those as well because we want to, and average all the scores of a game. And the way we do that there is we average the metascore of all the occurrences of the game where the name is like something. So this does use a like, again, to not be case sensitive. But the title wants to be exact because, again, we just want like the Witcher 3 Wild Hunt scores. And so again, we see, that lack of a wild card, but a card when we want to be exact. User scores, all the same stuff, pretty much, just using user score. To show off the average, we'll average the Witcher 3's user scores. I think we looked at their metascores before. And so 9.27, basically, if you round it, for the user score of the Witcher 3 Wild Hunt from all 3 platforms. That's pretty good. And so we get through that. Release date is, again, something of a similar story because the date is text, but in the standard date, year, month, day format, we use a lot of the very similar stuff with less thans, greater thans, but we use likes instead of equals because we want to be able to search when it's just a year or a year and a month. You can't do just months or days because the wild cards come after, but again, so we have this case of so search for all games on a specified date. So date near and dear to my heart, my birthday, and just one game came out on my birthday. But so you can also then do search for all games in 1999. And we want to do that and so that's where the likes come in and the wild card comes in. So because we don't really care about being specific all the time. We can be more specific, and that's the great thing about the wildcards is they let you be as specific as you want. If you want to be super specific, you can, and this I think really shows that methodology comes in. There's instances where we only want to be specific and instances where we don't care. So if it's like we're like a little specific, oh well. If we're not very specific, who cares, such as with the years. It does a lot of the same stuff, getting the names and platforms at dates, before dates, on dates, or counting all the stuff on those dates, just doing the counts of the names in comparison to those dates. So let us go back. Now this is where we do actually get a little different because we're using genres this time. As we know, that's a different table, so we have to do a join. But other than that, it's a lot of the same. We're using the likes because we want to be specific for the genre. We don't want ambiguity with the genre. We want the genre to be exact, so we're doing a lot of select the names and count the names and such with the genre like without a wild card because we want to be specific to the genre. But we do some interesting stuff here, such as finding the highest rated games and the lowest rated games for specific genres. And we do that using the max and the mins, and those return just the game that has the max or the min on a specific platform. The platform doesn't matter, but like overall, just the highest max or min score for a specific genre. And again, we're using some joins because the genre is a multi-valued attribute that has to be part of a different table, but they're joined through their IDs, so the IDs can match up. And that's why we use distinct to only get for the specific games we want. Because I believe you can see in a lot of these we use, like some of them we use distinct name, like count distinct name, select distinct name, and such. The min and the max gets our distinct. Just to show off the min and max, let's do the highest metascore of the let's do action RPG server. Mass Effect 2 has a 96, so that's quite high. And so you can just see it just gives you the highest overall score, not even per console, just highest overall in the database. Now, speaking of platforms on the 360, we can go to our platforms, and won't spend a ton of time here. Again, just a lot of the same stuff, getting all the platforms, selecting distinct, selecting our counts, where we use likes without wildcards because we want to be exact on the platform name. We do find some interesting stuff, such as where we're finding the oldest and youngest games on each platform, so we're using min and maxes of release dates, as well as the oldest and highest scores, so we saw those with the min and max scores. So those provide some new queries that we're finding where we have to use the min and max dates along with all these names and platforms. So let me show off one of those because they're different. You can also average the scores. As we've seen before, it'll average all the games across a platform. We saw the averages before. Specific games, this will average all the games across the whole platform. So let's search for the newest game on the Xbox One. That was Unpacking, released just about a month ago, this year of 2021. And just go back and look at some of the averages real quick. So you can average the scores. We basically just select the average user score from a game where the platform is equal to that. So that will find the average score from the platform for us. Pretty simple. Don't have to do a lot of intricate work for that one, which is nice. Now here we have something that is also a little bit different, which is our image searching. And so let me just show it off real quick with perhaps one of my favorite games of all time, Fallout New Vegas. It's taking a second to load. I think my internet is being a little slow. These usually works pretty fast, but my internet has been having some issues tonight. And so just to kind of show it real quick, the data in our for the images is actually like links to the images scraped from, oh there it goes, scraped from the Metacritic, and so then we use this URL lib request to retrieve that link from online. We send that link through this function that retrieves the link and downloads the cover to our computer, and then we open it in a file called coverart.jpg, and that gets stored onto our computer. And as we can see here, so that's the 360 cover. It will download all the covers it can find for all the games if there's only one. Luckily though, it only saves one file. We can show that real quick. So you see it's just the one cover art, despite having had multiple ones. So it's just the one cover art, and so that's how that works. That's how those queries work. They're a little different from what we usually have. And you can search whatever you want, or many games you want. So real quick, Halo 3. We'll give that a second. And so yeah, so it again retrieves the art from online. From Metacritic specifically, downloads it to the computer, but it luckily only downloads one file. There's Halo 3, and because it's only just Halo 3, that's it. It's done. Let's see. Now we can search for a mixture of attributes. I'll probably only show off about one of these, but there's quite a few different options that you can do. They all involve a specific character, again, or searching for certain characters. So again, likes with wildcards, but then mixing and matching rating, scores, less than equal to. So those are a lot of the same stuff with, the rating is equal or like, the greater than, less than equal to scores and dates and platforms, using likes to be exact, because we want to be exact with that stuff. But you could then mix and match that with your groups of characters. So one I think would be interesting. So find all the games that start with the released on the Xbox 360. All the games with the on the 360. You can also do, let's see real quick, just with rating. You can also see all games that start with A and have a T rating. And so that just, again, gives the user a lot more power and flexibility with their database to combine a lot of the queries we've seen before. These aren't anything new. These are a lot of the same queries, so they don't really need a lot of explaining, a lot of selecting names and doing distincts and, such with like platforms and using the likes and the less thans and the characters with wildcards and stuff. But it's mixing these queries together and combining them that gives the user a lot of power to look up interesting information. And that was kind of what I wanted to do with these. And finally, we just have some graphical representations of our data. So there's 6 different graphs to choose from. Here is a graph for looking up the all the games released in a year. You can see the bar graph. There's some circle graphs. So let's see a circle graph of the games starting with each letter. And here is a circle graph of all the games starting with different letters. And I think this is kind of interesting. I think, that's what I strove for with these graphs, was to just find and make cool and interesting stuff. And it's just a scatter plot of the Metacritic scores. I tried to make the graphs what I thought fit best for the data set to help visualize it. I just wanted to make some cool visualizations of some cool data that you could kind of query yourself to an extent, but this helps you visualize it. And these queries are, again, a lot of the same stuff we've seen before, but looping through in various regards. So looping through the years to find every year, but we used again where we have the year with a wildcard, so we're just getting 2020, and inputting that, or from the beginning to the end, so you get 20, or 2000, 2001, 2002, etc. And here we're just looping through all the letters, finding all the genres and everything, counting all the ratings and getting all the ratings, getting the average scores per year, and adding all those, and we basically put all these into lists and then visualize them. And it's, again, a lot of the same queries we've seen, just put through loops to kind of help us make some cool and interesting graphs. And that is it. I believe I have shown everything. I have described everything about the functionality of my database, shown how all of it works and how all of it can be used. Thank you for your time. I appreciate it. This was a very fun project, and goodbye.